Wonderful. Okay, so my story goes back to 1970. In fact, 50 years ago, the 13th of this month, I was at the Space Center. I was working in a thing called the Mission Evaluation Room. Now, the Mission Evaluation Room had 70 engineers and about 20 supervisors, and we were responsible for all the systems on Apollo 13. We were responsible for all the lunar lander systems, as well as all the command module systems. And my particular responsibility as an engineer in charge of the warning system was to let the astronauts know anytime there's any difficulty that might jeopardize their mission. It was called caution and warning. So there are two types of things that I was responsible for doing and designing into the hardware that was on board the lunar lander and the mothership. One was a warning indication, and the light would come on and it would indicate that there was a potential problem that might happen and that they could take some action. That was a caution warning. Now, there was another thing called the caution and warning. Yeah. There was another thing when there was an actual problem, it would indicate that they'd have to do something immediately. So here I was, I had my headset on, I was monitoring the spaceship. It was 208,000 miles from Earth, preparing to land, get ready to go toward the moon and do the things that would be required to land on the moon. It was about, I guess they may have had several hours, maybe hour left before they would actually circle the moon and prepare to separate the lunar lander from the mothership. Now, those of you, hopefully everybody's seen the movie Apollo 13 is actually watching and listening to me. Because if you've seen the movie, I won't have to go through a lot of details about how we went to the moon. But the whole approach included two spacecraft. One was the mothership, and then of course there was the lander. And I've got some things here to help you understand. Patrick, can you see this?
Yes.
Okay. Okay, I'm pointing to the mothership right here. This is the mothership, had a capsule here that had 3 astronauts in it. And then as they approached the moon, they would power up the lunar lander and the astronauts to land on the moon. 2 of them would go through a tunnel into the lunar lander and it would actually land on the moon. So they were at 208,000 miles from Earth. And, say this is Earth, you see Earth. And so they were, at a time, they were actually going to take their sleep period at this time. They were just about 55 hours into the mission, and they'd have a period of sleeping and resting before they actually did all the things that would be required to actually land on the moon. So at that time, there was a difficulty with a oxygen tank in this ship here. And the oxygen tank, there were 2 of them, and these tanks had liquid oxygen at a very cold temperature. And these 2 tanks plus the hydrogen tanks were located near them in the mothership. They would provide the electrical power through a chemical reaction of hydrogen and oxygen come together, and it produces water and air and electrical power. So those things are very important, and they're used for 2 weeks to keep this ship alive. So the astronauts can have water and breathe, and then they can have air, electrical power. So what had happened was that there was a malfunction in oxygen tank 2, and the 2 tanks are in the service module, but I have a little model here. So I don't know if I brought it into the room here. Oh, yeah, I got my model here. Okay. So here's you see my model of the craft? Okay. So these tanks are located right here. And one of the tanks, the oxygen tank 2, exploded. And it was a short circuit in the wiring that actually would stir the tank and monitor the tank pressure and so forth. And it actually blew out the panel, the tank blew up, exploded. And so what happened was the panel actually blew off, and there's an antenna. My model here doesn't have the antenna here, but the antenna would actually be the means by which they could transmit communications back to Earth. So here I was, I had my headset on, and I was in this mission evaluation room. I could actually see the console and the actual things that the flight controllers see. And this is what the particular, console looked like that. And all of a sudden, this particular television, it looked like it flickered. And after it flickered, just a moment later, I heard the word, "Houston, we've had a problem." And this is what it looked like. You see this picture? Can you see this picture, Patrick, right there?
Yep.
Okay. Well, that's me, by the way, the guy with the tie on. That's me way back in 1969. And so I saw that flickering happen, and I said, something's wrong. That thing shouldn't be flickering. Well, what had happened was that panel that had that tank blew out that panel. The actual panel came and interrupted the communications through the antenna back to Earth. So that was, I said, that shouldn't happen. She said, well, what happened was that was really an indication that there'd been a difficulty. And then I heard in my headset, "Houston, we've had a problem." And you're actually talking to the guy that's responsible for that very famous quote in space history. "Houston, we've had," because the reason they said, "Houston, we had a problem," because my alarm light, it's a red alarm light, and the astronaut saw that red alarm light come on. And then the other thing my warning system does is it rings a siren-like sound in the ears of the astronauts that have their headset on. So when they heard that sound, saw that light, that's when they said, "Houston, we've had a problem." So I'm the guy that actually was responsible for that very famous quote. You're actually talking to them right here. And it's the 50th anniversary. I'm an engineer. I'm an engineer responsible for the alarm system. I'm not an astronaut. I'm not a flight controller. And few people have a lot of interest in what engineers have to say, so I'm trying to build up your interest in hearing my story. So what I explained to people is that, yeah, there were 3 astronauts on board Apollo 13, but there was another astronaut. Now, he was a virtual astronaut. He's a virtual astronaut by the fact that he was looking over their shoulders. And his name is Jerry Woodfill because he put together the alarm system that would tell them if there was a problem. And so I was the virtual astronaut on board Apollo 13 because of all the work I had done. I had started working on that alarm system in 1965. When I came out of Rice University, most of the engineers were working on Gemini, and so I was a young engineer, and they assigned me the alarm system for this particular mothership. And what had happened was, shortly after I was hired in March of 1966, the fellow responsible for the alarm system in the lander, he left for a better job with higher pay. And so they said, well, Jerry, you have the alarm system for the command module, so we're going to give you the lunar landers as well. So I was the only guy in all of NASA. Now, I'm the only one in all of NASA that was responsible for the spacecraft caution and warning systems on both the lunar lander as well as the command ship, the command module. And so in that capacity, I would go to each one of the systems managers, and I talk to them. Like I go to the power manager and I say, now, if your system's not working correctly, what is the best way that I can tell the astronauts that they have a problem? And they said, for example, the engineer responsible for the command modules of power system, he'd say to me, well, there's 2 electrical buses, and they're supposed to be at 28 volts. If they descend, if that voltage comes down below 25.5 volts, well then, would you turn on your alarm system and turn on a light that says main bus B or A undervolt because that particular bus voltage is below what it should be? That's a warning. So I'd take that information and then I'd work out, I'd send an engineering order to have that particular threshold turn on alarm. So what happened was when this explosion happened and blew out their source of power, which was going to be the oxygen tank and the, you know, in the command ship, that indirectly pulled that bus voltage under that 25.5 volts. So that level I set, you hear, you know, if I could play that, in fact, I don't think I can, I'm used, but I've recorded what the astronauts said. They said, Houston, we've had a problem. We've had a main bus B undervolt. That meant that my alarm system, the result of that explosion had pulled that bus voltage down under the threshold that I had set. And so that's what turned on that alarm light, that red light. There were 3 lights, by the way, that were red, and they're positioned so the astronauts could always see them. And it started that alarm tone. Now, the alarm tone, if you've seen the movie Apollo 13, the sound of the alarm is much different than it actually was. In the Apollo 13 movie, if you go back and listen to the movie, it's that's about what it sounds like. But actually, it didn't sound like that. The design of my design had it sounding like this. Is that coming through, Rob? Well, what it was an every 2.5 seconds, it would alternate between, I think, 800 hertz and 2,000 or 2,500 hertz. So it'd be a tone. Now, that was the alarm for the mothership. Now, the alarm for the lunar lander, this ship, it was a different sound, and it was just a 3,000 hertz sound. A steady sound, okay? So they heard the alarm. Now, I got to thinking about this. I was taking a shower this morning. By the way, when I have these video, I have to prepare myself for these things, and I have to make my hair look right. And I don't have much hair. At least what little I got to make it look right. So I was thinking about that today, and there's a series on the internet. If you guys want to Google it, Google Jerry Woodfill and spell my name right, Woodfill. No telling what you get if it's spelled right, Jerry Woodfill, and then put in Universe Today, and you'll come up with 13 things that saved Apollo 13. So over the years, starting in 2010, I came up with this idea. It would be great if I could look at all the things that actually saved Apollo 13. And so Universe Today and I collaborated, and we put together the 13 things that saved Apollo 13. Well, came the 2015, the 45th anniversary, and I came up with 13 more things. And now it's 2020, and I still came up with another 13 things. So really, there would have been 39 things. But because of everything being shut down, they've only come and published on the internet. It was just yesterday. They put in the first of the final series. It's done by Universe Today. And so you can Google that, and you'll see that one of the things I put up with the Universe Today people was the fact that on Apollo 13, because the fact you had to power everything down, the heat for keeping the thrusters ability to actually control the attitude of re-entry, those thrusters there, if you couldn't keep them warm and they froze up, the plumbing did, they couldn't actually re-enter and they lose their lives. So that's the thing, the first thing I put into my final series, and that was the fact that they had to keep those thrusters warm or the crew could not re-enter Earth's atmosphere. Well, anyway, back to the, I get distracted. So I was there for, I guess when I had departed, I was thinking about this, that when the vehicle exploded, it was nearly 55 hours into the mission, and they were preparing to sleep. Now, can you imagine, just because they were kind of ahead of things, they were doing well, they'd already gone into the lunar lander, and they checked it out and partially powered it up. And but if they would have gone in and actually gone to sleep, which they should have according to their checklist or their way of, a checklist is like a cookbook. That is, you go through each procedure the astronauts do, and it's time to sleep, or you sleep. Well, because of other things, they didn't actually start sleeping. They should have been asleep an hour or two. They should have been asleep at the time that the explosion happened. Now, can you imagine, had they actually been asleep at about 55 and that explosion would have happened? It wouldn't have been Houston, we've had a problem. You know what they'd have said? They'd probably been expletives. What the, happened? That wouldn't have looked very good. Instead of Houston, we've had a problem, it would have been another statement that wouldn't have been worthy of being published. So it didn't work like that. And I always say it was probably God's providence that made it happen. And Jim Lovell agrees with me. Jim Lovell says that one of the things that saved their lives was exactly when the explosion happened. Because if it would have exploded a lot earlier in the mission, they wouldn't have had enough consumables in the lunar lander in this vehicle to make it all the way around the moon and back to Earth. If it had happened later, when they had departed with the lunar lander from the mothership and actually even on the moon, and that explosion would have happened in the mothership, it would have just been Jack Swigert up here and Hayes and Lovell on the moon, and Lovell and Hayes, they could have tried to get into the ascent stage and launch from the moon, but there wouldn't have been the consumables, the oxygen, the power, and all those things that were needed to get back to Earth using this as a rescue ship. And they all could have perished together, maybe, in the mothership, even if they docked up. And if they couldn't get off the moon, well, then there weren't enough consumables in the mothership to get back to Earth for Swigert, so he'd have perished. It would have been just an awful situation. So I'm starting to share with you guys just how desperate it might have been had it happened at a different time rather than at 208,000 miles from Earth. So there's so many things I could share with you folks about what saved Apollo 13. I have said there were 39 things that I've come up with. And a few of them I'll just share in the time we have. Patrick, how long do you want this thing to go?
I said about 45 minutes to an hour. I mean, whatever time you've got.
Okay, so we've been in it maybe if we about 20 minutes, I guess. Mm-hmm. So I'll give you some of the ideas and some of the things that will help you to understand. And then, how many people are watching right now, do you think, Patrick?
It says we've got 58 people in here, or 59.
Okay. Okay, so each one of you folks, you promised me you're going to go watch the movie Apollo 13. And then if you haven't seen it already, you'll understand some of these things I'm throwing out as I talk to you. Okay, so here's another thing that I often share about why we were able to save the astronauts. Remember I had shared that the oxygen tank 2 was the one that exploded. Now, oxygen tank 2 was on the outer perimeter of the service module. Oxygen tank 1 was interior to 2. Okay, now the explosion happened because of a problem that they had when they had tried to take those tanks out for some kind of a servicing. In one of the earlier missions, when they had the actual spacecraft on the Saturn vehicle, the Saturn V vehicle, they had to remove the actual tanks from the vehicle. So to do so, they had to take kind of a forklift, and they got up to the point where these two tanks were on a shelf. And they put the forklift, the two tines of the fork underneath the actual panel that those tanks were installed in. Now, those tanks were like eggs. You know, it's Easter time and you have eggs. And in fact, we dyed Easter eggs with the kids, our grandkids here last Saturday before Sunday. And after we dyed those eggs, we put, you know, the first egg would go into one of the little holders for it. The second egg got into the other. We'll pretend these tanks are like two Easter eggs, tank 1 and tank 2. So they went underneath with this forklift, the actual holding panel, and they lifted it up. Now, what had happened, in order to remove that panel, there were 2 bolts on the panel. And the bolt that was interior to the perimeter was nearest tank 1, and somebody neglected to unfasten the bolt nearest tank 1. They did unfasten the bolt near tank 2, so when the forklift, you know, tried to lift up that panel or the shelf where the 2 tanks were in, the O2 tank 1, where the bolt was not removed, it wouldn't go, but O2 tank 2's bolt that was on the outside, it lifted up, and they immediately said, oh, this is not correct. So they pulled out the fork. Well, what happened when they pulled out that the fork, the panel fell down, and tank 2, because it had a bolt that was removed, it was jarred and it hit, and the force of that shock that when it hit displaced a tube in the tank that was used to actually take the oxygen out of that tank. So that is the genesis of why tank 2 failed and not tank 1. Now, I always say that this was one of the many, many things that was providential, because if they would have reversed those bolts that were not done correctly, tank 1 would have been the one that exploded. And had tank 1 exploded, that was in the interior and above those oxygen tank or hydrogen tanks. And because it was within, it would have caused both tank 1, tank 2 to explode, and it would involve the hydrogen in tanks hydrogen 1 and 2, and it would have just destroyed the whole vehicle, and the men's lives would have been lost. That's how close it came to being a catastrophic, fatal failure, rather than one that we could recover from and bring those guys back to Earth alive. So there's so many things I could share with you. I've got all kinds of props here to do it. I always do this particular thing because it has to do with the scene in the movie. If you've seen the movie, probably the most famous scene in the movie is how they come up with a way of making the filters in the mothership work in the system in the lunar lander. Now, astronauts require the ability to take carbon dioxide out of the cabin. You know, they breathe out carbon dioxide when they take in the oxygen. And you have to remove the carbon dioxide or they'll get drowsy and eventually, you know, fall asleep and then perish if you don't remove carbon dioxide from the cabin. Well, see, I'm the alarm system engineer. So there's a sensor that monitors the content of carbon dioxide in the cabin atmosphere. And what had happened was the mothership is designed to take 3 men 2 weeks in space. But the lander is designed for 2 men, just to go to the moon's surface and collect moon rocks and come back and then dock up with the mothership and go back to Earth. Well, this particular ship has just enough filters for 2 guys for 2 days. Now you have, because we had to go from the mothership into the lander, the mothership would no longer work, and you had to use this as a lifeboat, and not enough filters. The filters for the lunar lander, those filters were round, and there weren't enough of them to get the guys back to Earth. And so here's my round filter right here. I got it at a auto parts store to show the example. Not enough of these. Now there are 24 of these that I made from a AC filter I got at Kroger, but I had to cut it down to make it look right. And so if I could make these filters work in the round barrel for these filters, I could save their lives. And now I need to share this with you. We worked in a group called the Mission Evaluation. We were the engineers. After the Apollo fire that took the lives of 3 astronauts, the head of the Apollo program said, we need to have a group of engineers that are on station during every manned mission, so that if we have a problem we've never seen before, we can actually go to these guys that were the designers, that knew all about how all the systems on board these ships work, so that if we had a problem we've never seen before, these were guys we could go to. Well, this was a problem that no one ever expected. How do you make a square filter fit into a round hole? And so that's when they called on us, the Mission Evaluation Room, to solve the problem. And one of our engineers, it was in Crew Systems Division, part of our group, he came up with this concept. It's in the movie. How do you make the square filter fit into the round system? Well, when he came in, he said, let's get all the things that we know are on board the spacecraft, and let's just put them on the table or put them out and see if we can come up with an idea of how we can fix it. And he knew that on board Apollo 13's lander, the lunar lander, where's my little model here? Well, here it is. Okay. So he knew on board this thing, the astronauts, when they get in their spacesuits, before they go onto the moon, they use a fan. This fan blows air into their spacesuit, and before they detach from the cabin atmosphere and use their backpacks, the oxygen in their backpacks, to actually go onto the moon. So this fan, they used this fan, and this fan, you can plug a hose into this fan. This is my hose that I got at Toys R Us. Toys R Us is not around, but my hose is. Okay. So what they do is this fan actually, it works like a vacuum, and it's pulling air. It's pulling air, around the cabin. It's actually circulating air around the cabin and through their spacesuits too. So we got this hose, and we got these square filters. Now it'd be nice if you could just put the thing right. It's not going to work like that. You got to do it with, be clever about it. So he says, here's what I'll do. He says, guy's name is Ed Smiley and his group there. He knew there were plastic bags on board for, suit parts and so forth. So he cut a slit, and I think, let's see if I got a slit. Yeah, there it is. So he put a slit in this bag, and this fan, can blow air in this bag. And then if I take this square filter, and put it at the mouth of the bag, you see like that. I just got 2 hands here, and it's hard to hold everything right. But that's not going to work. And the reason it's not going to work, you see this, everybody? It's not going to work because it's, it doesn't fit right. It doesn't fit right. So what's going to happen? Well, the only thing that can save their lives is this stuff. You see this stuff? It says, what does it say? Duct tape. So duct tape made it possible to seal up that square filter around the bags and whatever they did, and then with that hose, and that saved their lives. And so I always appreciate that, because I like to play the guitar. Now Patrick came down here, and here's my guitar. You see this? And I've got a song about duct tape. Okay, are you ready for this, Patrick? Now listen to my song. This tells the story. Well, their spaceship exploded 200,000 miles in space. Too few round CO2 filters, man. Just was in their face. Now the damaged mothership had plenty that were square. But how do you make a square filter fit into a round hole? Was their prayer. So they looked around that spaceship to find a way, and they found something that just might work that day. No rocket science was needed for this device. An old roll of duct tape would I always enjoy doing that song. That's the only song ever written about Apollo 13 stuff. Okay, so now they've got enough air to breathe. They're on their way back, and they're approaching Earth. And there's another 35 things I could share with you, but I want to do what few I'd like to highlight before our time is up together. And if you want to know about all of them, here again, go to the internet, Universe Today, Apollo 13, Jerry Woodfill, and you'll find everything you ever wanted to know. You know, I've studied this since 1970 when it happened. So if you study something for 50 years, you're going to have a lot of ideas that come to you and ways of sharing. I give about 60 talks a year, and this is my 5th talk since we've been, had to stay away from the Space Center. And so now they're coming back to Earth, and here's our Earth right here, and here's our moon over here. And there's a difficulty. Now, if you watch the movie, this is one of the best scenes in the movie, because there's this unexplained thing going on. It seems that Apollo 13, as it's coming back to Earth, it seems like it's going above Earth's horizon. There's some kind of a thing that's causing some kind of a thrust. They call it a thrust effector. That is a vector of some kind of a propulsion thing, action reaction. If you're taking science or physics, you know that every action there's an equal and opposite reaction. Well, something's making Apollo 13. They don't know what it is. It's going to miss Earth altogether. It's called the shadowing. The angle is shadowing, and they're going to miss Earth altogether. So the retro officer, to make sure that that doesn't happen, he calls for them to fire thrusters in the lunar lander to bring it back within the Earth's, path, so they won't miss Earth. Now, this is another thing about Apollo 13. When the explosion happened, it blew insulation and all kinds of particles into space. And astronauts, the way that they navigate in space are like a Boy Scout or a Girl Scout. They use the sighting of stars. You can tell where stars are and so forth. And they have they call it a sextant, and they look out this sextant and they see the stars, and they can determine where they are in space by their star sightings, and they punch the numbers into the computer through a displaying keyboard. And at Apollo 8, Jim Lovell had sighted the star. And remember Jim Lovell, they went around the moon on Christmas Eve and read from the book of Genesis. Well, Jim, after they had read from the Bible, they sighted the stars in order to come back to Earth. Now, Jim got this, and he went to put the numbers into the computer, and instead of pressing the enter key, he hit the erase key, and he erased everything. Well, a friend of mine down the street had worked on a program that you didn't need to use stars. You could use what they call the terminator line of the Earth, between the illuminated and the darkened portions of Earth. And then you could sight that sextant on that terminator line, and then you could navigate that way. And in the movie, they do a marvelous job. You have Tom Hanks as Jim Lovell. He's saying, he's sighting that terminator. It's a great scene in the movie. And then you got Jack Swigert. He sets the time of the burn. I don't have my watch on, but he times how long they fire the engine aimed at that terminator line of Earth. And then Hayes, he's controlling, I think, one of either, I think the yaw or something of the spaceship. And Hanks is controller is controlling the pitch. Okay, so they fire it, and that's one of the other things that saved their lives. And they did the same thing on Apollo 8. Lovell was the navigator on 8, and guess what? He's now the commander of Apollo 13. He did something already that he needed to do to save his life on 13, so he's already done it. So many things, it seems like it's providential. So, okay, the retro officer, he calls for this particular maneuver so that they wouldn't miss Earth altogether. Now the weathermen come to the retro officer and they say, retro officer, we've got another problem. What's that? He said, well, we've got a hurricane. A hurricane? Well, that's not so good because it's coming towards the landing site in the Pacific Ocean. And if, I don't think we'd survive landing in a hurricane, but it looks like that's going to happen. And okay, now here's another thing. The entry capsule has what they call a inertial measurement unit. It's basically gyros that turn, and gyros, if you have a gyroscope and you spin it real fast, it keeps its particular position. And so you have three of these things, and there's 3 axes, and they're spinning. And so anytime the spaceship turns, the gyro platform, it stays the same. So because it's stable and you turn the spaceship, you can know exactly where your spaceship is pointed. The only problem is the gyros for this thing, they're supposed to be warm. They're supposed to get a period of warming. And we don't have the luxury of the power to keep those things spinning for a long time. We're using the lunar lander system, the gyro system, not this one. But now we're going to have to turn them up just a couple hours before entry so that we'll have the entry capsule be correct and everything. So will they work? Okay, so the retro officer thinks, what am I going to do? I got a hurricane. Are my gyros going to be accurate? He wonders this. When the explosion happened, he thought, when that explosion happened, what if the actual pressure of the gas from that tank exploding, there's a tunnel in the center of this service module. What if that pressure came up and so thrust something that actually came up through that tunnel and hit the heat shield and cracked it? That would kill them right there. So you have all kinds of things that meant they may not live. The hurricane, the heat shield being compromised, the gyro's not working. And now, he's saying, what am I going to do? I often tell this story because, I'm a believer, and I got a letter from a school teacher. She said, Mr. Woodfill, in this letter, she says, my kids were really concerned about Apollo 13. Little Wanda came into her classroom and said, teacher, there's a real problem. I heard about it on television this morning that the astronauts are going to die in a hurricane. What can we do? Well, the teacher, she asked the kids to pray, and these kids are praying. And the retro officer is thinking, I'm going to ignore the weatherman. I'm going to assume that shallowing thing is going to stop. And it did. He didn't know why, but it turned out it stopped because the lander was the thing causing that actual change in the shelling angle. And when you jettisoned the lander, got rid of it, it was stable. And so it didn't continue to shallow. So he brings it down. Now here, if you watch the movie, it's a great scene. We always know in Apollo and all the earlier manned missions, Mercury, Gemini, exactly when we're going to restore communications. What happens is when you begin to come through Earth's atmosphere, it's a phenomena. And what happens is that the atmosphere, air particles and all, when you come through them real fast, they heat up. And they put up what's called a plasma layer, and radio transmission can't get through those ionized particles. And so there's no way of talking to the astronauts on communications while they're reentry. But we always know to the second when you can begin to talk once more to the astronauts. And for Apollo 13, that time came when they should have been able to communicate with them, and they couldn't. They couldn't, and so the thought was, we've lost them. They've died. Either the gyros haven't properly worked, or the angle was improper. Something's happened, and we've lost them. So you see in the movie, they show how worried Gene Kranz is and so forth. But a little bit over a minute, all of a sudden, they hear, Houston, we're on the mains. And they were on the main chutes, and they can't, sometimes it's hard to get through it. To have worked in that and see God save 3 men because of our efforts. So I don't know if I can go on any longer. I've got to choke down. So what I would like to conclude with, Patrick, is everybody out there, all 58 of you, here's the thing that I wear this wristband every day. It says, You see that? Failure is not an option. This side says, I have the right stuff. And every time I give a talk, I lead everybody that's heard my talk in a pledge. And this pledge makes you an honorary Apollo 13 flight controller. So here's the way I do that. I ask you to put your hands on your hearts. Okay, all 58 of you out there. Patrick, put your hand on your heart.
All right,
now,
Jerry.
Okay? And all 57 others of you, I'm going to make everybody, you guys. Now, Patrick's at least been made an honorary flight controller. How many times, Patrick? At least once, right?
I think, yeah, probably 2 or 3 at this point.
Okay. And he probably has one of these wristbands.
Yep,
you know?
I got mine on.
Oh, you got yours on. Okay, so I'm going to lead you in the pledge, okay, guys?
All right.
So hands over the heart, and I'm going to give you you can turn your mics on so I can hear you. I'll say it, and you say right after me. After I say each thing, you say it right after me so I can hear you, okay? So everybody activate your mics so I can hear you. Ready? So here we go. I will do my best.
I will do my best
to achieve success in my goals.
To achieve
That's my goals.
Neither fear,
Neither fear,
failure, nor frustration
failure, nor frustration
shall overcome me.
Shall
overcome.
I am unstoppable,
I am unstoppable,
unmovable,
unmovable,
and unshakable.
and unshakable.
Failure is not an option.
Failure is not an option.
I have the right stuff.
I have
I have the right stuff.
So you guys are now all honorary Apollo 13 flight. So Patrick can probably send you a picture of what the card looks like, and your teachers, whoever, can print it out on cardstock and cut it out and put your name in there, and you can show people that you're now an honorary flight control because you took Jerry's pledge that made you one. Okay, so that's my conclusion of my talk, and I thank you, Patrick, and everybody that came and heard me out again. So go watch the movie, go to the internet and see all those other things I wasn't able to share about what saved Apollo 13. And remember that failure is not an option, and you all got the right stuff. Godspeed.
All right. Thanks so